Hi guys, so in this video and in the next couple of videos, I'll explain matrices, some concepts from matrices, basis transformation, and SVD. We'll also solve some problems from them by hand, and I'm doing this because some of my friends from class told me that they didn't understand the mathematics behind SVD and PCA. So I want to build the mathematics from scratch, and I'm pretty sure if you watch all of these videos, um, start to end, you should be able to understand what's going on under the hood. So this is basically for my course CS 556, which is Mathematics of Machine Learning. And I'll start with some basic concepts from matrices. Okay, so the first thing I want to explain is the inverse matrix. What is the inverse matrix and why do we use it? So I'll explain this with an analogy. Suppose I have a number 8, right? And the reciprocal of 8 is 1 by 8. Similarly, in the matrix world, if I have a matrix A, the reciprocal of this matrix is A inverse. That is the inverse matrix. So everything that happens with the reciprocal in the real world also happens with the inverses in the matrix world. So if I multiply 8 by its reciprocal, I get 1. Similarly, if I multiply the matrix A with its reciprocal, I get the matrix I. This is the identity matrix where all the diagonals are 1 and every other element is 0. So the identity matrix in the matrix world is similar to having the number 1 in the real world. So now you might ask that I can just divide 8 by 8 and also get 1. Why can't I just divide a matrix by itself and get the identity matrix I? Well, the answer to this is that in matrices, there is no concept of division by a matrix. I mean, seriously, the concept just doesn't exist. So if you want to divide 10 by 2, you can either divide it by 2 or you can multiply 10 by the reciprocal of 2. Since there's no concept of dividing by a matrix, what you do instead is that you multiply A by the inverse of some other matrix to get some answer, right? So that's what the inverse of a matrix is. And it's also important to note that A inverse A is also equal to A inverse, which is equal to I. Okay, this is similar to 8 into 1 by 8 equals 1 by 8 into 8 equal to I. So that is basically what the inverse matrix is, and the identity matrix is a matrix where all the diagonals are 0. Sorry, all the diagonal is 1 and every other element is 0. So that's inverse and identity matrix. So let's say I have x a equal to b. I have the values of a and b and I want to find the value of x. How do I do this? Since I can't divide both of this by a because division in matrices doesn't exist, I multiply both the left and the right hand side by a inverse. Okay, so this gives me xi equals ba inverse. Xi is just equal to x because I is equivalent to 1 in the real world, right? So this is just x equals ba inverse. Now it's important to note that order here is very important. If I multiply a inverse to the left, a inverse xa, then I have to multiply a inverse to the left of b also. Order here is very important, and in this case I can't write this as ix or xi. Okay, if I want to convert this into the identity matrix, I have to make sure that a inverse is multiplied onto the right of a. Okay, this is important to understand. Now, one last thing that I want to cover before I move on to bases in the next video is that it is possible that the inverse of a matrix may not exist. Okay, in the real world, you always have the reciprocal of a number, but in matrices, it is possible that the inverse may not exist. So if you have a matrix, a 2 by 2 matrix, and you want to find its inverse. What you do is you just change A and D, okay, and you give a negative sign to B and C, right? And you divide this by the determinant of A, B, C, D. Okay. Now, if A determinant is 0, then the inverse of this matrix will not exist. And if the inverse of a matrix does not exist, inverse does not exist, then the matrix is called a singular matrix. Singular matrix. Okay, this is important. Not every matrix has an inverse. And if you want to find the uh, the inverse of a 3 by 3 matrix A, B, C, D, E, F, G, H, I, then what you do is that, well, you have to follow a few steps. In 3 by 3, it's not as simple as calculating the 2 by 2 inverse. So in 2 by 2, you just change A and D's position and you give a negative sign to B and C. In 3 by 3, it's a little different. You have to first find the minors, then you have to find the cofactors, then you have to find the adjugate, and then you have to find and then you have to just multiply it by the reciprocal of the determinant. Okay, reciprocal of the determinant. I'm not going to cover all of that in this video because it's simple and there are lots of sources online for this. In this video, I just want to set the basis, or sorry, I just want to set the foundation for what is to follow, what will come later on, and like all this will be used in SVD. So in the next video, I'll explain what bases are.